Hey C Block, Mr. Buxton here. Quick video to explain how to do one of the problems on the homework, and my hope is that after I explain this, you can go over with your groups and sort of fill in any parts of the homework that you had a hard time with. Um, this video probably will go a little bit quickly, so if you want to pause it and go back and watch part if it was confusing, help each other out, that would be awesome. All right. So I'm going to go over number 2 on the homework, which was the first one that I asked you to do. And you were given this equation here, y is equal to negative x plus 1 squared plus 4. And the first part that you were asked for is the translation from our parent function y equals x squared. And so this plus 1 here moves the graph to the left 1. And then this plus 4 at the end moves the graph up 4. So if the original vertex of our parent function was at 0, 0, and I go left 1 and up 4, our new vertex is going to be at negative 1, comma 4. And I'm going to plot that point, negative 1, 1, 2, 3, 4, right there. So there's negative 1, comma 4. And then we're asked for the y-intercept. So to find the y-intercept, we need the places where x is equal to 0, because where x is equal to 0, those are going to be points on the y-axis. So we can take our equation and we can plug 0 in for x. So y is equal to negative 0 plus 1 squared plus 4. And 0 plus 1 is 1. We square that, we get 1. Multiply by negative 1, we get negative 1. And plus 4, negative 1 plus 4 is 3. So we get y is equal to 3. And you know that I like the intercepts as points. So we can write that point as 0, comma 3. And we can go back up and plug that point in on our graph. So 0, comma 3 is right there. Next question asks for a symmetric point from 0, 3. So if we look at our graph and we see where the vertex is, the axis of symmetry is going to be a line here at x equals negative 1. So our symmetric point for 0, 3 is going to be right on the other side of the axis of symmetry at negative 2, comma 3. Let's just write that here. So this one is negative 2, comma 3. For our x-intercepts, we want to plug 0 in for y now. So I'm going to rewrite this equation as 0 equals negative x plus 1 squared plus 4. Let's subtract 4 from both sides. So I get negative 4 is the opposite of x plus 1 squared. Divide both sides by negative 1. We then take the square root of both sides to get rid of the square. And we get plus or minus 2 is equal to x plus 1. And then if we subtract 1 from both sides, 2 minus 1 would give us x is equal to 1. And negative 2 minus 1 would give us x is equal to negative 3. And again, I'm going to write those as points. So they have a y value of 0. So we have 1, comma 0. And we have negative 3, comma 0. Right? And I'm going to go plug those in on our graph too. 1, comma 0. And negative 3, comma 0. So there's a point here. And there's a point here. And it makes sense that, by the way, those are symmetric as well. And then the last part asks us to get one last point and its symmetric point. So you can pick any other number you want to plug in for x. I'm going to plug in 2 for x. So we would get y is equal to negative 2 plus 1 squared plus 4. So 2 plus 1 is 3, squared is 9. The opposite of that is negative 9, and plus 4 is negative 5. So this gives us y is equal to negative 5. So we plugged in 2 for x, so our point is 2 comma negative 5. Go back up to the graph. 2 comma negative 5, 2, 3, 4. So we have a point right here. And then the symmetric point, since that's 3 away from the axis of symmetry, we can go 3 away the other side. And then that point would be negative 4 comma negative 5. Let's go back down to the bottom and write that in too. So negative 4 comma negative 5. One other thing quickly, besides plotting all of these points to do this, we can actually use what Elena was saying on Monday in class, that since our regular graph went over 1 and up 1, and then over 2 and up 4, and over 3 and up 9, and this graph doesn't have a vertical stretch or compression. It does have a flip, so we can go from our vertex and we can go over 1, down 1. Let's see if I can show this. So we can go over 1, down 1. We can go over 2, down 4, over 3, down 9, over 4, down 16. And then you can get all those points. And so for the graph, we can fill it in because the graph is continuous now. And draw that parabola in. And you can get a pretty accurate graph because going through the right points of y equals negative x plus 1 squared plus 4. So now if in your groups you can go through that, maybe explain some of this to each other if parts of it were a little confusing, and then see if you can correct numbers 3 and 4 on your own, and follow the rest of the agenda. Thanks, Seabuck. Have a good weekend, and I will see you. Never mind.